All right, like I said, we're on page 393 in the book today, and we're going to be covering angles of polygons. All right, first, before we talk about angles of polygons, we're going to define a diagonal. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. And non-consecutive vertices just means vertices that are not next to each other. So if we draw a quadrilateral and label these vertices A, B, C, D, all right, a diagonal connects non-consecutive vertices. So if we connect A and C, AC is a diagonal. In a five-sided shape, if I call this point up top point X, and I connect non-consecutive vertices. Now, I would connect X to Z. X to Z would be called a diagonal. And then I can connect X to A, and X to A would be another diagonal. All right? Non-consecutive vertices. Consecutive vertices are next to each other. All right? X and Y, those are consecutive vertices. They're next to each other. Obviously, you can't connect those because they're already connected by a side of the polygon. So a diagonal of a polygon is a segment that connects any two non-consecutive vertices. Now, theorem 6.1, you need to be sure you get that in your notes. And that is the polygon interior angle sum theorem. And it states that the sum of the interior angle measures of an n-sided convex polygon is the formula to find out the sum of all the interior angles of a shape, convex shape, is n minus 2 times 180. Where n is the number of sides. If you have a shape, you take the number of sides, subtract 2 from it, multiply that times 180, and it will tell you what all of the angles inside of the shape would add up to. So we already know that the angles inside of a triangle sum 180. And we know that a triangle has 3 sides. But just to show you how the formula works, we could find the sum of the interior angles for the following polygons. So if the polygon, if we start a column here and we use its name, all right, we can call it a triangle. And then over here, we could call this sum of interior angles. We could build a little table, okay? And maybe this middle column would be number of sides. So if we got a triangle, it's got 3 sides. So we take 3 minus 2 and we multiply it by 180. All right. 3 minus 2 is 1, and 1 times 180 is 180. Quadrilateral. Quadrilateral has 4 sides. So we take 4 minus 2, multiply it by 180, and we get 360. So all of the angles inside of a 4-sided shape have to add up to 360 degrees. There's a table on the top of page 394 that would be helpful for you to refer to throughout the assignment today. It gives you the number of sides and the name of each shape all the way up to 12 sides. If we had to find the sum of the interior angles of an octagon, octagon has 8 sides, so we take 8 minus 2, multiply that by 180, and it tells us what the angles inside of that shape need to add up to. So we got 6 times 180, and I get 1080 degrees. a dodecagon. Looking at the chart, a dodecagon has 12 sides. So we take 12 minus 2, multiply that by 180. And we get 1800. So the angles, the interior angles of a 12-sided shape have to add up to, or will add up to, 1800 degrees. Anything over 12, we use the term engon, meaning if you're asked to find the sum of the interior angles of a 15-gon, it's referred to as a 15-gon, meaning it has 15 sides. So you would take 15 minus 2 and multiply it by 180. So that's 13 times 180, 2,340 degrees. Now, you need to know that because if you look at example 1 on page 394, the next progression is to find the missing sides or to find missing angle measures inside of polygons. So let's say that you get a 4-sided shape. ABCD. Angle B is 90 and angle C is 90. Angle D is x degrees and angle A is 3x degrees. And we need to find the value of x. So in this case, the first thing we need to do is determine what the 4 angles need to sum. Okay? Now we just did that, right? Quadrilateral. What do the angles sum in a quadrilateral? 360. So angle A plus B plus C plus D, those 4 angles added together have to equal 360. So we go 3x plus 90 plus another 90 plus x has to equal 360. So if we combine our like terms, 3x plus x, that's 4x. 90 plus 90 is 180. 4x plus 180 has to equal 360. If we subtract 180 from each side, then our 4x is equal to 180, and then divide each side by 4, and we have our value of x. 45. So in this case, x is equal to 45. Any questions? Let's do another example. It's the guided practice down there on the bottom of 394. 1, 2, 3, 4. It's a 5-sided shape. We got, let's see, H, J, K. L and M. All right, angle H is 2x degrees. J is 142. K is 2x again. L is 3x plus 14. And so is M. So these 5 angles, we've got a 5-sided shape. First thing we want to do is find the sum of these angles. So the sum of the angles is going to be 5 minus 2 times 180. So 3 times 180, 540 degrees. The 5 angles need to sum 540 degrees. So then we're going to take the given angles and we're going to write an equation. So I'm going to just start here at angle H and I'm going to go clockwise. Meaning I'm going to take 2x plus another 2x is 4x plus 3x is 7x plus another 3x is 10x. So we got a 10x, and then I'm going to add together the 142 and the 14 and the 14. So 142 plus 28 is 170. So 10x plus 170 has to equal this 540 degrees. So now we can solve for x. It's going to subtract 170 from each side. So our 10x is equal to 540 minus 170 is 370. And then divide both sides by 10. And our x is equal to 37. All right, so there's a couple of examples of how you can find the sum of the angle measures of a polygon, and then how you can use that sum to find the value of variables, and or if you had to find these different angle measures, you could just substitute this 37. So if you needed the measure of angle H, that would just be equal to 2 times 37. $74 degrees. And if you needed the measure of angle M, that would be 3 times 37 plus 14. Which is 125. All right, so you could substitute the value of the variable into the equation or into the expression that represents each angle to find each angle. All right, any questions? All right, your practice for today is going to be on page 398. Problems 12 through 19. And then as a reminder, the assignment is due when you finish these problems. So as soon as you can get these problems finished, please go into Focus and complete the electronic assignment. I leave it open for multiple days for people that are absent or had to go on a field trip or miss class for some other reason. It's not left open to wait till the last minute to get it submitted. So please don't do that. Please get the assignment. If you're here in class, get the assignment finished, get the electronic assignment completed and submitted.